on mobile browsers, on all platforms, on desktop browsers, etc. Here's another cool demo that Greg wrote that shows depth of field effects. The grass in the background is blurrier than the grass in the foreground. Again, pretty standard 3D graphics techniques, very difficult to do without access to the GPU, but now entirely possible with WebGL. But it's not limited to just 3D content. Okay, here's a pretty cool electric flower demo. It shows all sorts of overlaid, 2D, opaque, and translucent layers. Rendered using the 3D API, but it's obviously not a 3D scene. Okay, so because you have access to the GPU, because you have access to shaders, you can come up with all kinds of different visual effects. You can run them really fast and display them in the browser. It doesn't have to be just walking around in 3D. Now, one point on performance. So I mentioned the type array specification. This is actually a very old demo by NVIDIA that was originally developed to show off the Vertex Array Range extension for OpenGL. And nowadays, that functionality is built into WebGL. The point here is how quickly can a program, like a JavaScript program on the web, upload Vertex data to the graphics processor. This is a key benchmark, because if you want to do anything like a flight simulator with dynamic terrain, you're going to need to generate a lot of vertices on the CPU and then upload them to the graphics processor. So let me just show you how many vertices are actually being sent. Okay, so every dot on that screen is being computed by JavaScript code every frame. And we're still getting about 20 frames a second of a massive, fairly massive number of vertices. If we scroll down here, we can see that we're getting about 3.5 million vertices generated per second. And this is going to get faster. I mean, all the browser vendors are working on optimizing these typed arrays so you can upload more Vertex data every frame to the GPU and get more and more complex scenes into your WebGL app. So I'm really excited about the possibilities here, and you're going to see more stuff coming. And finally, really quickly, just in terms of games. So some years ago, some crazy guys in Germany ported Quake 2 to Java. You may have heard of this. It was called Jake 2. And they basically transliterated the C source into Java. There was no object-oriented change or optimization done. It was a straight transliteration and was coded to one of the Java OpenGL bindings. So more recently, a crazy team in Atlanta, Georgia at Google that makes something called the Google Web Toolkit. This is a compiler that actually translates Java source code to JavaScript. So you can run your Java programs on the web. It's nuts. Not only did they apply that compiler to the J2 sources, they also wrote a WebGL binding for Java so that they could basically take the Java port of Quake 2, recompile it, and run it on the web in WebGL. So, crank the volume here so you can hear it. So, you get the point. You can waste all day on this. Yes, that's it, right? Quake 2 running a web browser with no plugin. It's pretty awesome. And this is part of the kind of content that you're going to see enabled by this technology. So, very exciting time. Thanks.
Running WebKit. Again, it is a prototype project, so you don't expect to see that in the first phones released here, but this is where we want to be. We want to work in the frontier here and showcase that WebGL is something that we want to further investigate and see what kind of great performance we can push to mobile phones in order to use WebGL. So, any questions, please come and visit me in the booth, the Sony Ericsson booth, where we also show more demos of WebGL.